Hello, my name is Andrea Bengoa, and I'm going to be presenting my key activity, which is about weight and balance. This activity contains introduction, methodology, results, and the conclusion. At first, I would like to start by quoting Gina Love, who said balancing on a rope requires skill, steady feet, and steady mind and sense control. As you can see, the act of balance consists of several things. Some of these things may be small, but at the same time necessary to put the act together. Introduction. So there are many factors in the safe and efficient operation of an aircraft, including proper weight and balance control. This project will show the correct way to calculate the weight and balance, including pilot, co-pilot, passengers, luggage, and fuel of a Piper Turbo Aero 4, including graphics, pictures, and the results of one example. There are many factors in the safe and efficient performance of an aircraft, including weight and balance calculations. It is important to calculate the weight and balance of an airplane to make sure that the flight operates safely without being either AFT or forward. While some general aviation pilots may forget, the airlines are a prime example that this must be done before each flight. Even if a weight and balance is done incorrectly, it can certainly cause many fatalities and drastically decreasing the performance of an airplane. In the theoretical framework, we learned that the weight times the arm is equal to the moment, and the arm is equal to the moment divided by the weight. There are four important measurements that we need to calculate by adding up or subtracting the weight at the moment. Those are zero fuel weight, the ramp weight, the takeoff weight, and the landing weight, which determine each precise moment. The ramp weight and the takeoff weight are different because when you drive the aircraft through the start and then to the run-up, it consumes fuel. The loading arrangements give you the arm per section of the plane. It comes in the pilot's operating handbook, and it is important to know where you're placing your objects precisely, because sometimes young pilots make the mistake to do their calculations of their pilot's bag based on the baggage compartment, when they really place it in the rear passenger seat, so you can access it more easily. The loading graph can be useful for a bunch of stuff, for a lot of easy pre-made calculations, but is usually used to calculate the load moment of the fuel. The load moment is divided by 10,000. The center of gravity moment envelope is very important because that's what tells you the performance of the aircraft and what performance it is going to have. We have two categories, the utility and the normal. The utility, you have no luggage or passengers, light airplane, and higher capacities, two things on air. You have more maneuver ability. And the normal, you do not intend to do acrobatic operations, having up to 9 passenger seats and a maximum takeoff weight of perhaps 5,500 kilograms. Our variables are that the distance compartment and the weight compartment depend, I'm lying. The least force depends on the total weight, and the distance compartment and the weight compartment are independent to the momentum of compartment. So the momentum of compartment depends on the distance and the weight compartment. That is because in our hypothesis, we said that if we have more added weight in the airplane, like passengers or luggage, the amount of fuel we can carry decreases. These are some of the results that we have. Some of them were made by hand, and the other ones on the right side were made by an app. So we use the materials of the weight and balance chart, the list of weights and balances, a pilot operating handbook, paper and pencil, scale, and a calculator. The data shows that the weight and loaded aircraft moment are changing constantly. At the landing, we saw that we moved to the utility category because all of the fuel burned. So we are able to see how it's continuing to shift. So for a future project, we can see how burning fuel affects center of gravity, and we can see it changing. It would make what would it make if we drop a passenger midway with your luggage and how it would affect the center of gravity. Some people may think that the weight and balance is not important because our phone can do it or an iPad apps can do it. On the other hand, in the check ride, your check ride examiner will want to see you do it in the old-fashioned way because you need to know where each number comes from. It's not enough just to put it on the app. You need to know where everything comes from for the safety of the crew and passengers. Because there are plenty of accidents caused by being lazy and not doing the weight and balance. These are the resources, well, the pages I visited to make this project, and thank you for your attention.